So the first task in looking at systems of equations is just to understand what the end game is. What does the nature of a solution to a system of equations look like? So here I have two equations, each of which has both an x and a y in it. And we need to decide whether or not a given ordered pair, in this case it's the ordered pair negative 4, 5, is or is not a solution to this system, which is a different question than just asking us to solve this system without giving us a possible candidate for a solution. Right? This is a little bit quicker of a problem. So if I just want to know whether this ordered pair is a solution or is not a solution, what's my quickest way home here?
Substitute the numbers in.
Yeah, substitute the numbers in. And so my question then is, which of these numbers plays the role of x and which plays the role of y? Because they don't actually tell us that in the problem.
Well, x is usually the first one.
Yeah, x is usually the first one. That's a convention. That's just something that algebra people agreed upon just because it gets used so often in a graphing context. So we'll treat x as negative 4 and y as 5 and just substitute those values into each of these two equations. And in order to be a solution of the system, what do we expect to happen when we make those substitutions? What has to happen if we're going to answer this question? Yes.
They need to equal each other.
Yeah, they which need to equal each other.
The y, they have to solve for both sides.
Yes. And not only that, in both equations.
Right.
In both the first equation, if I substitute a negative 4 for x and a 5 for y, and then also in the second equation, if I substitute a negative 4 for x and a 5 for y. So here my x was negative 4, my y was 5. When I substitute those x's and y's into these two equations, both of these equations need to be true in order for this to actually be a solution. We're talking about question 1 on the 5th problem set and kind of working our way backwards to the 4th and the 3rd before the exam. So let's check. First of all, let's look at the first equation just to get us some arithmetic practice. How would I evaluate 3 times the quantity negative 4 minus 5? What would I do first? What operation? Yeah, I would look at parentheses and ask, can I simplify what's inside the parentheses any further? And I really can't, because negative 4 is as simple as it's going to get. So then my parentheses are not important. I don't have any exponents. So then what comes after that?
Multiplication.
Multiplication. And so the multiplication that I have here, so here's my equation. The multiplication is 3 times negative 4. And 3 times negative 4 is negative 12. Whoops, and I dropped a negative sign when I copied this over. And then negative 12 minus 5, that's negative 17, rather. So the first equation is indeed satisfied by this x and this y. So what else do we need to do? Check the second equation. So the left-hand side is 5. The right-hand side is minus negative 4. What's minus negative 4? What does that evaluate to? Positive 4. It's the opposite of negative 4. And so my second equation, 5 equals 4. Okay, so what do we conclude now?
Negative 4, 5 is not a solution.
It's not a solution. And it's not a solution because even though it satisfies the first of these two equations, it doesn't satisfy the second of these two equations. Right? And so because it doesn't satisfy the second equation, it doesn't satisfy the system. It's not a solution to the system of equations. It's not enough just to make one of the equations true. That pair would have to make both of the equations true, and in this case it doesn't.